on the envelope detector lasted a whole lot longer, and the ripple was not as great. So overall, from this, you can gather that there are POWs that perform better than others, and the POW actually does work. So that's good. The next measurement was measuring POW gain versus transmit power. The question here is POW gain consistent over a whole range of transmit powers? The setup is very similar. We had the same transmitter with an adjustable attenuator, except we took away the query command. We just transmitted CW or POW. We then measured the voltage on the output of the charge pump with a voltmeter, and we used DC power relationships to determine POW gain. The results are plotted on this graph. Another a little complex. This is POW gain on the vertical axis versus transmit power on the horizontal. And the first thing to take away from this is that POW gain is not constant over transmit power. We would prefer it to have flat lines, but it didn't happen that way. What you can see here is that the 1, 2, 3, and 4 POWs start out with negative POW gain or a POW loss. This reduces range. But as you increase transmit power, there's this almost linear trend in the log-log scale, an increase in POW gain. So that implies a very simple empirical relationship between POW gain and transmit power. Likewise, you get a similar gain, although it's kind of hard to tell if it's linear or not, in the Gaussian POWs. At a transmit power of negative 1 dBm, you see this drop-off in POW gain, and we haven't performed enough research to determine whether that's a characteristic of the charge pump itself or if it's actually voltage clipping on the output of the charge pump on the WISP. The WISP uses a electrostatic discharge diode that prevents the, large spikes of voltage on the output. So if a POW, a very potent POW, is input to the charge pump, you could have situations where the voltage wanted to spike, but it got clipped, fell back down, that reduced output power. So the thing to take away from this is that POW gain is not consistently positive in any case, but some POWs perform a whole lot better than other POWs. So seeing the sharp Gaussian POW performing a lot better than the 1, 2, 3, and 4 POWs gives us confidence that even though envelope detection was a problem before, we can make some modifications to where it'll work better in the future. So that about wraps it up. The things you can gather from this presentation are that the POW actually works, and we tested it on the WISP, which is a passive wireless sensor, and we're confident that the POW can work in a whole lot of other areas. POW gains depend on transmit power and maximum voltage. There are no necessary WISP changes needed to make a POW work. However, you can improve the performance by increasing capacitor voltage on the envelope detector and on the output of the charge pump, but not necessary. In the future, we plan on measuring POW gain versus POW period and looking into applications of POW beyond range improvement. It turns out that you can measure the range of tags using POWs in much the same way that you can measure objects using radar. So that concludes my talk. Thank you very much.
Thank you. All right, we have a question already.
Yeah, the concept of POW looks very interesting. Like, I was just wondering, POW has the concept of large bandwidth and controlling the envelope. So is it not similar to a chirp which starts from a low frequency, goes up to a high frequency, and when you actually correlate it, it also has those spikes in between, and it also has large bandwidth and enough gain. So, like, I was just wondering what's the difference or the advantage of POW over a chirp signal?
Chirp. Yeah. Well, I think you're referring to a chirp that doesn't change in amplitude. It's just a slow frequency
changes, yeah.
waveform that the frequency just gets faster and faster and then goes back down. Well, the thing about POW is that it works on charge pumps. So it's specifically designed to increase voltage magnitude over the diodes, because diodes have a pretty constant threshold voltage. So increasing frequency doesn't help that much unless you have an impedance matching network on the input. So maybe the frequency you inputted in that you use a chirp on, some of the frequencies will pass, but some will get rejected. But the whole idea of a POW is to increase voltage magnitude, not just have a large bandwidth.
So we can consider chirp as one of the potential, like we can actually use chirps on WISP as well and try to see whether it performs.
I think it's possible. If you have a impedance matched charge pump, then it's definitely possible. You might be able to get better gains.
Would it be better just to stay at the frequency?
It would be. Yes, the POW presents some problems when you increase the bandwidth because the impedance matching may not be broadband enough. But there are some POWs that you can make, like the 1 POW or 2 POW, which have very short frequencies or very narrow bandwidths. Yes.
Are you interested at all in the regulatory implications of
Oh yes.
modulated?
The last time I presented this, I had a guy who gave me all kinds of crap
Your fault, probably.
about the FCC regulations and all this.
Even if you're not interested in the FCC part, another interesting aspect is broadening the transmitter spectrum makes it more difficult for readers to coexist in the same space.
Oh, absolutely. Yes, and we're looking into other ways of using POWs at the same time. You can have orthogonal POWs, I and Q. You can also have tags which use spread spectrum coding, so you can transmit at the same time, but you can just use your codes to demodulate, and then using tags at different frequencies, for instance. We're just brainstorming right now, haven't really put any scientific effort into it yet, but it's definitely something we're going to look into in the future.
Any other questions? All right. Well,
Thanks.
thank you. I think he'll tell us about some of the more recent developments.
I tried to look about the distance to use it. Is it okay? Can you hear me? Okay, thank you for the introduction. Actually, I was coming here to meet Kevin again. Quite a long time since we met last time. So I'm presenting you our prototype platform. It's somehow similar to the WISP, but the motivation for this platform was completely different, and I will explain you during the talk. So, but before, you might not know us. In Europe, we are in the crypto and in the RFID community quite known already, but here you might not know. So we are coming, I'm coming from Graz University of Technology. Graz is the second biggest city in Austria. I'm from the computer science faculty. There is an institute which is called Institute for Applied Information Processing and Communications. A very generic name because when they started, they didn't really know what to do, I think. This was before I was there. In fact, we are doing IT security. So at the moment, we are about 55 researchers doing their IT security research from crypto to e-government. There is also some more famous guys in this institute. So this is Vincent Reimann. He is one of the two inventors of the advanced encryption standard. And this is Reinhard Bosch, our head of institute. He's kind of famous in Europe for his e-government things. He's an advisor for ENISA and for the Austrian Chancellery. But they are definitely not important for this work. So I am leading a group which is called VLSI and Security. We are actually interested in hardware design for crypto, but application specific. So we are not doing yet another gigabit crypto module, but we are trying to deduce our requirements from real applications and then trying to build a hardware IP module, instruction set extension, whatever, that fulfills these requirements. And RFID is a very demanding topic in this sense. A couple of years ago, this guy, he's the most cited researcher in my group, Martin Feldhofer, came up with an AES module, which is still the smallest, I think, so AES and for advanced encryption standard. We designed a module, we produced it and showed that it is really possible to do standardized crypto operations even on passive RFID tags. So this was our first success. We went on working in this topic and we started this RFID-SAC conference a couple of years ago. This is when I met Kevin, and I think in 2010, probably Kevin will organize this conference this year, or next year it will be, 2011, sorry, 2010 it will be in Istanbul, which is also a very nice place. Meanwhile, there is also an Asian branch of RFID-SAC, so you can go also next year to Singapore for this conference. So what was the motivation for building this semi-passive platform? It's actually a prototyping platform. We are doing crypto, and it's very hard to explain people what we are doing. And when it comes to RFID, people were